Hi students, problem number 11. A train A takes 50 seconds to cross a 400-meter long train B, moving at a speed of 20 meters per second. So there are two trains A and B. The second train B is moving at a speed of 20 meters per second and in the opposite direction. It would take 100 seconds to cross a pole. The same train A takes how many seconds to cross the train B is 50 seconds. But it crosses a pole, fixed object at how many seconds? 100 seconds. So find the speed of the train A in meter per second. A very good question this and it has been asked many times in different competitive exams. So understanding the problem requires some time. Okay. Now there are two situations. So first let us take there is a train A and this is a train B. Now the speed of the first train A is S1 and the speed of the second train B is S2. The length of the first train is L1 and the length of the second train is L2. So these are the symbols we had been using in all the numerical problems. Whichever is given, we will have to substitute that. And the first time, in the first situation now, it takes 50 seconds to overtake. So I will take T1 is equal to 50 seconds. This is the first case. Now in the second case, the first train only is coming to the picture A and it crosses a fixed pole, fixed object. In a time T2 is equal to 100 seconds. Okay, so this is 100 seconds. So T1 is 50 seconds and T2 is 100 seconds. Train A length is not given. So let L1 be equal to L itself. And the speed of the first train S1 is also not given. So let us use the symbol X. And in this second case, second train B is moving at a speed of 20 meters per second. So second train here S2, its speed is equal to 20 meters per second. And T2 we have written already. So the train B is having a length of 400 meters. So I will take L2. So L2 is equal to 400 meters. So this is case 1 where one train is overtaking the other train. So the total length covered must be equal to L1 plus L2 and in a time equal to 50 seconds. So I will write the equation for the case 1. So time taken T1 must be equal to the total length is L1 plus L2 divided by both the trains are in opposite directions. So I will change the sign. S2 is opposite, okay, in this direction. So here S1 plus S2. If they are the same direction means it would have been S1 minus S2. But they have given clearly in opposite direction. So the speed of the second train in the opposite direction is 20 meters per second. So the relative speed of both the trains will be equal to S1 plus S2. Okay. So now this implies what? This implies the time taken T1 is how much? 50 seconds. Is it not? So for T1 we have to substitute 50 on the left hand side. Okay. The length of the first train is not given. So I am taking the symbol L plus length of the second train is L2 equal to 400. So L plus 400 divided by S1 plus S2. Speed of the first train is not given. So I will take it is X plus speed of the second train is 20 meters per second. So this is X plus 20 and this is our equation 1. Are you understanding up to the first equation? The total problem I have divided into two steps. Okay, at the beginning stage of learning we have to do like this only. So in the first stage, two trains are crossing in the opposite direction. So the crossing distance must be equal to the total sum of the lengths of the two trains L1 plus S2, and the relative speed of either of the trains is equal to what? S1 plus S2. So using that, I have got the equation number 1. Right. Now in the second case, very simple, only one train is going to cross. So the train is having a speed x meter per second and it is crossing a fixed point. So how much distance is traveled by the train while crossing the pole is equal to the length of the train L1 itself, isn't it? So its length is L. Therefore, this time T2 must be equal to, the length of the train L divided by its speed x, its own speed x. But in how much time it is given? 100 seconds. So T2 must be equal to what? 100. So I am writing now 100 is equal to L by x, and therefore L is equal to 100x, and this is our equation 2. Are you all understanding up to second equation? In the second step, only pole is a fixed object. So when the train crosses the pole, how much distance it should have covered, it's equal to own length of the train. So L divided by its speed is not known, so L by x. So cross multiplying, L is equal to what? 100 times x is the second equation. Two equations we have framed. In the first equation, in place of L, I can substitute 100x. In place of L, what I can substitute? 100x. So that only one variable will be available, isn't it? So 50, rewriting this equation 1, now 50 is equal to, in place of L I am writing 100x plus this 400. Okay, numerator has become 100x plus 400. And denominator is x plus 20. So denominator as it is x plus 20. So only one variable x we have got. Okay. So that only is to be determined. Find the speed of the train A, that is equal to what? X. We have to find the value of x only. Okay. So cross multiplying, I can write 50 into x plus 20. 50 multiplied by x plus 20 on the left side. On the right side, you see here 100x plus 400. Shall we take 100 as the common factor? So this is 100 into x plus 4. So this is x plus 4. Easily cancelling numbers have come. Left side 50, right side 100. 52s are 100. So 50 is cancelled with 100 2 times. So x plus 20 is equal to 2 into x plus 4. So x plus 20 is equal to 2 into x, 2x, plus 2 into 4 is 8. So left side is 20 minus 8. So 2x minus x, like that I can write. So 2x minus x is equal to 20 minus 8. Therefore x is equal to 12 meter per second. Very beautiful numerical problem in the trains. So this is very interesting, son. Understanding the concept is very important. Okay. So which of the option is correct? Let us see now. So find the speed of the train A in meter per second. Okay. Okay. Now option 12 is the, option B is the correct answer. Okay. That is correct. Suppose if the problem is extended, find the length of the train A also they may ask sometimes. So what is the length of the train L? So L is equal to what? 100x, is it not? So we will find out that also. So length of train A. So what symbol we have taken for the length of the train A? L1 is equal to L. This is equal to 100 into x. Is it not? So L is equal to 100 times x. So 100, so this is equal to 100 into 12. So this is 1200 meter. So 12 into 100 meter. Like that also sometimes they may ask both the length as well as the speed. I hope you must have understood well. Fine.